Alright, so this is a video for Chapter 6.4. In 6.4 we learned more ways of factoring. We're on page 486 in your textbook. We're going to look at your chapter review and practice 5 problems. Let's start by looking at number 21. It says factor. Basically, all of these instructions are to factor. So we have 81 minus 100 y squared. I literally say ignore the instructions and pay attention to the word that says factor. All you need to do is worry about is factoring. If you pay attention to it saying factor each difference of two squares completely, you're going to go around and try to memorize what is the difference of two squares. Instead, you should look at a form like so and know how to factor it regardless if you know what it's called. So the instructions for chapter 6 is plainly just factor. Alright, so I look at this and I want to factor it. And I know we talked about the form a squared minus b squared is the same as saying a plus b times a minus b. Well, like we said in class, the first term helps you determine the a. So 81 is going to help me determine the a. It's a number, so the rule is take the square root. The square root of 81 is 9. The second term, 100y squared, is going to help you determine the b. Well, there's a number on it, so I take the square root and I get 10. There's a variable part, so the rule is to keep the variable and divide the exponent by 2, and I just get y. So my a is 9 and my b is 10y. Once I have it, all I do is fill it in. So I have 9 plus 10y times 9 minus 10y. And yes, it's now done. So the great thing about chapter 6.4 is that they're teaching us 4 new forms, but if you memorize the forms, once you have the a and the b, all you gotta do is plug it in. Alright, let us look at number 32. It says factor again, x squared plus 1. Well, we had the form a squared plus b squared is equal to prime, meaning I can't factor it because of the plus sign. Well, this is in that form. 1 is a perfect square root, and look at the even power here. As a matter of fact, let me go back up here. How did I know this was in that form? Because 81 is a perfect square, as well as 100 is a perfect square, and the power, or the exponent, is even. Same as here. 1 is a perfect square, and the power here is even. So this is the sum of squares, which is prime, because I cannot factor it. So that's prime. Alright, number 34. And we have 18xy squared minus 8x. And again, my instructions are to factor. Well, first of all, I notice that my two terms actually have stuff in common. So this time I need to factor out the GCF first. So between 18 and 8, I believe the highest or the largest shared factor among them is just 2. So I'm going to factor out a 2. And then I see an x and an x. So let's factor out the x. And that's the only thing they have in common. So I'm left with 9y squared minus 4. And then we pause for a second. We notice that 9 is a perfect square, 4 is a perfect square, and the exponent is even. So it must be the form a squared minus, because of the minus sign right here, b squared, which again was a plus b times a minus b. So like before, we got to find the a and the b. Well, the first term helps you determine the a. There's a 9 on it, so let's take the square root and we get 3. There's the variable part, y squared. The rule is to keep the variable and divide the exponent by 2, so it's just y. And then the second term, the 4, helps you determine the b. So the square root of 4 is 2. So then all you do is fill your answer in. Now don't forget the 2x is hanging outside, so there's your 2x. And then you have 3y plus 2 times 3y minus 2. And it's factored. Good. Alright, now let us look at number 42, then number 43. So it says x to the third power minus 27. And again it says factor. So this time I notice that my power, or my exponent, is no longer even. He is actually 3. And 27 is not a perfect square, but it is a perfect cube root. So it should take me to this form. A to the third power minus b to the third power. And it's minus because it literally says minus. And that's going to become a minus b times a squared plus ab plus b squared. So again, all I need is the a and the b. The first term helps me determine the a. Well, the rule is to keep the variable and divide the exponent now by 3. So a is just x. And the second term, which is just 27, do not touch the minus sign. That is there to help you figure out which form to put it in, is 27. So the cube root of 27 is just 3. So again, if it's given to you as a number, take the cube root. If it's as a variable, keep the variable, divide the exponent by 3. And then all you do is fill it in. So I got x minus 3 times x squared, because remember, a squared is the same as saying a times a, plus a times b is just 3x, plus b squared is literally b times b, which is 9. And that is factored. And then the last one is number 43. 64x to the third power plus 1. Okay, well, notice again that the exponent is 3, which is a multiple of 3. 64 is a perfect cube, and so is 1. If you're not used to your perfect cubes yet, that is fine. Just pay attention to the exponent. It's 3. Therefore, it's in the form a to the third power plus b to the third power equals, well, this becomes a plus b times a squared minus ab plus b squared. So the first term helps me determine the a. So there's a 64 on it, which is a number, so it tells me to take the cube root, and that's just 4. There's a variable on it, so it tells me to keep the variable and divide the exponent by 3, so it just becomes 4x. And then the second term, the 1, helps you determine the b. And since that's a number, the rule is just take the cube root, and that's still 1. Once you have the a and the b, all you gotta do is fill it in. So this becomes 4x plus 1 times, well again, a squared means a times a. So 4x times 4x is actually 16x squared minus a times b, which is 4x plus 1, and that also is factored. So chapter 6 is all about factoring. 6.4 added 4 more methods to your factoring. The main thing about these methods is if you have the a and the b, all you need to do is plug it into the form. If you have the a and the b, all you need to do is plug it into the form. Just literally plug it in. Alright, as always, let me know if you have any questions.